My name is Michael Davis, and this is my recitation assignment for recitation number 4. Um, the question asked us to calculate the pH of 50 milliliters of 0.200 molarity solution of hydrochloric acid after the following amount of 0.250 molarity of sodium hydroxide have been added. You can see our chemical equation there, and the milliliters that I was assigned for the first problem was 16 milliliters. So to calculate this, first what we have to do is to find the limiting reactant. We do that by first converting our 50 milliliters into liters to get 0.0500 liters. And then we're going to solve for the molarity of hydrochloric acid by multiplying 0.0500 liters times 0.200 moles of hydrochloric acid. You can see what we get is 0.0100 moles of hydrochloric acid. And this was actually provided in the question, so there's not much thought in that arithmetic. Okay, so for my problem, I got 16 milliliters. And first what I have to do is first I'm going to convert milliliters into liters. And I'm going to do that by simply moving the decimal point over. So I'm going to end up with 0.016 liters. I'm going to multiply that times 0.25 moles of sodium hydroxide divided by 1 liter of solution. And that's simply just a molarity. We get that from our question here. That's in the problem. So that's basically molarity, 0.250 moles of sodium hydroxide times 0.016 liters. And we're going to get 0.0040 moles of sodium hydroxide. We know that sodium hydroxide is our limiting reactant because it is the lesser value of the two. So we use the limiting reactant to move forward in our problem. We then have to find how many the moles of hydrochloric acid reacted away, because that's our excess. So to do that, we take our limiting reactant, start with the limiting reactant. So you're going to take this should be 0.016. I'm sorry, I have to correct that, but it should be, let's correct that really quick. One moment. Okay. 0.016 liters times 0.250 moles of sodium hydroxide, and divided by 1 liter times 1 mole of hydrochloric acid, and the moles here cancel out for the sodium hydroxide. You're going to end up with 0.0040 moles of hydrochloric acid that are reacted away. Then you have to find out how much hydrochloric acid is left over. You do that by taking the amount that you started with, which is 0.0100 moles of hydrochloric acid, and that's from our first equation. You subtract that from the moles of hydrochloric acid that reacted away. You got that from this equation here. We calculated the moles of hydrochloric acid. You subtract that, and you end up with 0.006 moles of hydrochloric acid left over. To calculate pH, you first have to divide the total moles of leftover divided by the total volume, which is simply 0.05 liters plus 0.016 liters. And we get this here, 0.0660 liters. And you're going to simply multiply that into your moles of hydrochloric acid that was left over, 0.0060 moles of hydrochloric acid. And you end up with a molarity of 0.091 molarity of hydrochloric acid. pH is equal to minus log um, the hydrogen ion, excuse me, and we know that the hydrogen ion is equal to our molarity. You see this here. So you just kind of plug in your equation, plug in your values into your calculator. You're going to end up with 1.04 pH. For our original question was to calculate the pH of 50 milliliters of 0.2 molarity solution of hydrochloric acid after the following amount of sodium hydroxide, 0.250 molarity of sodium hydroxide, have been added, and that pH is 1.04. Okay, that was my first question, excuse me. My second question, my second problem that I was assigned was 50 milliliters. So we're doing the same, basically the exact same question, same problem. We're just kind of working with different numbers here. So instead of 16, we're now working with 50. The process is the exact same. We're first going to find our limiting reactant. This time, though, the limiting reactant is hydrochloric acid. And we know that because when we do our calculations for moles of sodium hydroxide, we're going to use 0.500 liters, which is basically 50 milliliters turned into liters. And we're going to multiply that times 0.250 moles of sodium hydroxide. And we end up with 0.0125 moles of sodium hydroxide. That makes our hydrochloric acid our limiting reactant. And that just, we just got to do an extra step at the end of the equation when that happens. And we'll get to that in a moment. So we first have to find how much of sodium hydroxide reacted away, because we know that that's our excess. We have no hydrochloric acid remaining because that's our limiting reactant. But to calculate that, we're going to start with our limiting reactant, which is 0.0500 liters times 0.200 moles of hydrochloric acid. The liters cancel because we have this molarity here, basically moles over liters. And to convert, to get to moles of sodium hydroxide, you divide 1 mole of hydrochloric acid into 1 mole of sodium hydroxide. The moles cancel, and you're left with sodium hydroxide, moles of sodium hydroxide. And you're going to end up with 0.0100 moles of sodium hydroxide reacted away. We next have to calculate how many moles of sodium hydroxide are left over. And we do that by starting with our original amount of sodium hydroxide in our original calculation, which was 0.0125 moles of sodium hydroxide minus 0.0100 moles of sodium hydroxide gives us the amount that's left over, which is 0.0025 moles of sodium hydroxide left over. Now, normally what we would do, if we were working with hydrochloric acid, this should not be here, but we would just simply take the moles of sodium hydroxide, the moles divided by the volume. We're going to still do that for this problem. Ignore this, this should not be here. But the moles of sodium hydroxide over the total volume will give us the molarity, 0.025 molarity of sodium hydroxide. Now, because we're not working with hydrochloric acid, we have to do a different step here when we're calculating the pH. We have to calculate the pH of hydroxide itself. Now, that is equal to minus log times hydroxide. Now, the hydroxide is equal to the molarity of sodium hydroxide, just the OH part itself. So essentially, the hydroxide that you're going to use in your equation here is 0.025 hydroxide. And if you calculate that, you're going to have negative log, times 0.025 equals 1.6. That 1.6 is not your answer. However, to get your answer, you are going to need it. You would simply take the pH in this situation will be equal to 14 minus 1.6 equals 12.40. And that is our pH for this equation, for the using sodium hydroxide as your excess. It's a little bit different than using hydrochloric acid as your excess, like we did in the first problem. But that is the extra step you take. You subtract 14 from your negative log times hydroxide to get your answer when you're not working with hydrochloric acid. Okay, this completes my video for recitation number 4, and I thank you.